Alright, so we're going to review a really important topic for chemistry, stoichiometry. So let's begin. Ammonia, NH3, is produced from the reaction between nitrogen gas and hydrogen gas. If we begin with 25 grams of hydrogen gas, we're assuming an unlimited supply of our other reactant, how much ammonia can we make? Now the first thing you need before you can do any stoichiometry is a balanced chemical equation. So we need to remember nitrogen gas and hydrogen gas are both diatomic. So that's N2 and H2. And then NH3 is ammonia. Now we need to ask ourselves, is this equation balanced? Looking left to right, you'll see 2 nitrogens on the left and only 1 on the right, 2 hydrogens and 3. Okay, so this isn't balanced, so let's quickly balance this equation. We need a coefficient of 3 and a coefficient of 2. Now our equation is balanced, and we want to list what we know. We know that we've got 25 grams of nitrogen gas, and we're looking for the amount of ammonia that we can produce. So the first thing we're going to do is we're going to convert our starting material into moles. Unfortunately, it wasn't given to us in moles, so that means we need to take the mass of nitrogen that we were given and convert it into moles using the molar mass. Alright, so where does this number come from? This is the mass of nitrogen times 2, right, because it's N2, so that's how we get this 28. We set up so that grams of nitrogen cancel out, we're left with moles. We multiply straight across and divide. This is the number we come up with. Now we're going to carry out lots of extra decimal places, and we're going to round to our correct number of sig figs at the end. We don't want to round to the correct number of sig figs here because we've got 2 more steps. And if we round now, we'll have an accumulation of rounding error. So we're done with step 1. We're going to take this answer of moles nitrogen gas, and we're going to move on to step 2. Now we're going to multiply by the mole ratio. Remember, this is why we need to balance our equations. So we start with the amount that we just finished with, the 0.89286 moles of nitrogen gas. Now where do these numbers come from? Well, there are 2 moles of NH3 that are produced for every 1 mole of nitrogen gas that is consumed. Alright, so we set it up again. We want the substance that we're trying to get rid of to go on the bottom, and we want the substance we're trying to retain to be on the top. That way, when we multiply straight across and divide, we get rid of the nitrogen gas and we keep the ammonia. So 0.89286 times 2 divided by 1. Now again, we're going to carry out extra decimal places and round at the end. So now we're in moles of NH3, but that's not what the problem asks for. The problem asks how many grams of ammonia can we make. So what do we need? We need to take this number of moles and convert it to grams, which means we need the molar mass of ammonia. So this number is the mass of nitrogen times 3 times the mass of hydrogen. Now this number goes on top, right, because we want grams to be kept. We want moles to go away. So we take our number from the previous step, multiply by 17 divided by 1. Notice our moles of ammonia cancel. We're left with grams. Now this gives us this number when we punch it into our calculator, but we can't retain all these decimal places because our original number only had 3 sig figs. So we have to round our final answer to 30.4 grams of NH3. And that's our final answer.